Yes, well, I think Richard doesn't need a long introduction. I think I always introduce him as the biggest figure of AI from Germany, outside of Germany. He's driven a lot of NLP research, at a PhD in Stanford, built an AI company, sold it to Salesforce, was the head of AI at Salesforce, the chief science officer, and is now competing with Google. It's also investing a lot. Great to have you. I saw you talk already yesterday. Actually, I think today you will give a variation of that, but it was, I think, was very well received yesterday. So yeah, let's kick it off, and I think we'll also have some time for questions afterwards.
Thank you. No applause needed yet. Maybe it'll suck. Okay. Thank you so much. Really great to be here. All right. So I was told to maybe talk a little bit about my background and how I got here. So I'll share with you a little bit of my personal optimization path. Fun fact, this morning I created this with Stable Diffusion. So as the first image I threw in a talk, it's just like non-convex optimization landscape was the prompt, but we'll talk about that in a second. So I'm originally from Dresden. Was born in the GDR and then studied linguistic computer science at Leipzig University, Linguistische Informatik, for those of you who speak German, and was also an Erasmus exchange student in Montpellier for a year. Had a good time there. So, they striked for one of the semesters. So I mostly was studying by myself. But then we went to Saarbrücken for my master's. Was kind of a little bit disillusioned by the state of natural language processing. I felt like there's not enough math and real AI in the way we structured natural language processing back in the day. And decided to move into computer vision. I had a ton more math in it and the master's in Saarbrücken, and then did an internship at Siemens Corporate Research in Princeton, New Jersey, briefly. Actually, it was a pretty long internship. It was 6 months, and I realized during that time that everything I'd done before didn't matter at all. I took a ton of classes. I had almost twice the number of credits I needed for a bachelor's degree. And I still had gotten rejected from every good US university for my PhD. I was top of class in high school, I was top of class in my bachelor, none of it mattered. And during that internship, and just before that internship at Siemens Corporate Research, I was told, if you want to get into top school in the United States, you got to have a letter of recommendation from a person at a top school in the United States, and you got to have research publications. None of your classwork matters at all. I was like, oh man. I worked so hard for so many years, and it doesn't matter. If I want to get into a top PhD program, I gotta get these two things, and I only have 6 more months. And so during that internship at Siemens Corporate Research in Princeton, I also reached out to a professor in Princeton, multiple, but one actually had time. Her name was Fei Li, and she had just moved from UIUC, so she didn't have many students yet at Princeton, so she had a lot of time. And I basically worked 2 full-time jobs from 10 a.m. to 10 p.m. when the building closed. I worked at Siemens Corporate Research because my advisor there had great connections, I was told, to MIT and a few other places. And then I would come home, I'd nap for half an hour, and I worked till 4 or 5 a.m. On my Princeton sort of non-real job is for free, but I was trying to impress this professor in Princeton to write me a letter of recommendation after a few months of working together. That was not healthy. I actually struggle often with that when people ask sort of, oh, do you have career advice? I'm like, I kind of don't want to say work yourself to the bone, but like, that's kind of why I got to where I am. But it's not healthy. It was definitely not sustainable. I developed allergies. I had to learn how to use my mouse with my left hand because I couldn't move my right hand anymore enough, and I became ambidextrous in the process. But anyway, good times. I'm very happy it worked out. I got into the PhD programs after that. And then actually left Princeton after a year and went to Stanford because, Stanford is still better, also has better weather. And ended up, doing my PhD at Stanford. Was also, again, a little bit dismayed because there wasn't enough real artificial intelligence in the way they were doing natural language processing. Kind of went back to my roots in the PhD, and I saw all these PhD students kind of designing their features very carefully, right? If you were to try to build a sentiment analysis algorithm, you would, find a list of positive words and negative words, and then you would find like a negation feature of like not one of these positive words. And it's like, okay, that's an interesting feature. And then you would just use, SVMs or other tools to learn the weights of those features. By the way, who here understood what I just said, like at all? Okay, great. Pretty technical crowd. All right, excellent. Good to know. And so basically I was dismayed because it's like, this is graduate student descent. It's not, stochastic gradient descent. And I wanted to learn the features, and I was lucky because at the time, Andrew Ng had just started getting excited about feature learning in computer vision on like, very small 32 by 32 pixel images. And I thought, couldn't we use those ideas that they're applying to fixed sized images for natural language processing? And there are about 2 papers, one from Yoshua Benjo and one from Jason and Colbert and Weston, and Ronan Colbert and Jason Weston. And I love those 2 papers, but they were mostly ignored. In fact, the Stanford NLP group, one PhD student wrote in their reading group, they had read the paper, but they called it the bullshit ICML paper because they really hated those papers. But I actually love them. I thought they're really great. And they had ideas of word vectors, very rudimentary word vectors still. But to me, it became clear that everything should be a vector and everything should be learned end to end. And then I published my first couple of papers. I basically made a conscious decision. It's going to be a high risk, high reward scenario. Either by the end of my PhD, no one will care and it'll stay in very ORCID niche subject, or people will get it and it'll work and it'll be in a successful PhD. And so I just went all in and was crushed because all my first couple of papers got rejected. People are like, why are you submitting a neural network paper to an NLP conference? This is stuff that didn't work in the 90s. Why? And they just didn't read the rest of the paper, it felt like. And so first couple of papers got rejected. But, and the performance was often like at state of the art, but it wasn't like way above state of the art. And that was part of the problem. They could still say, well, it's not way better, so why do I care? I already know how to design my features. And like I did the stuff that it took them 10 years to do. And I did it in, a month, and it was all learned end to end. But they're like, that doesn't sound like a great thing, I think, for their career. I think they're worried because they had gotten so good at feature engineering that it didn't like the idea that an AI would automate what they got so good at. And I think that's something that is a lesson for startups too and other things in life. If you develop a new process and the process is automated, the people that did it manually are not going to be fans of your work. It's the nature of human psychology. And so at some point, the performance gotten way better. And I realized in order for it to learn more without any feature engineering, we needed larger data sets. So I started curating and labeling a ton of extra data sets in sentiment analysis, for instance. And then we could really show, wow, with this little bit of extra data, it was actually way better than any manual feature engineering that could have been done. Eventually, I won the Best Computer Science Thesis Award, but no one was still teaching the stuff. And so I thought, well, it would be really high impact if I was becoming a professor. I kind of accepted a faculty job, but then also Silicon Valley. And there's a lot of venture capital around, a lot of startups, and it's sort of in the air and in the water. And so I had several venture funds who just reached out and said, hey, this research seems very impactful. You already have thousands of citations as this like lowly PhD student. We want to give you money. And I had no business plan whatsoever. They're like, here's a couple $1 million. Just we trust you. You'll figure something out. This seems impactful enough. Just kind of insane. And I thought, I'll do it for a year and then maybe I'll transition to the board and I let some other people run it, but I'll give it a try. But then of course, I wasn't actually a famous professor who had tons of amazing PhD students who would then run their company for them and get all the credits. I was only, just graduated myself. And so the company would have imploded if I had left after, 6 or 12 months. At the same time, Stanford let me teach a new class, deep learning for NLP, sort of, again, a niche sort of class. There's still a real NLP class that my advisor was teaching. But that after 2 years or so, basically at that point, the field of deep learning and neural networks had overtaken everything. And Chris, my advisor, is like, I don't want to teach NLP anymore without neural networks. Why don't we merge the two classes and just make one class that is now based on deep learning? And that, after 4 years, basically now every NLP class, natural language processing class, includes neural networks. So I was like, okay, it's not that impactful anymore to do it, one of hundreds of these kinds of classes. So I also stopped teaching. Also, my teams basically grew too much, and it felt like a little bit like, why should I spend a lot of time with like one bachelor student on a small research project if I could work with someone who already has a PhD and wants to build something for like 12 months? It seems more impactful to mentor them on their projects. And so, long story short, I had started this company, MetaMind. We got acquired by Salesforce, became the chief scientist there, and eventually executive vice president, running a research group of a couple hundred PhDs, and then also a bunch of product teams that were actually taking that technology and pushing it into production and sales, service, marketing, automation, and a bunch of other customer relationship management things. And that felt really fun. You take a chatbot and you publish a paper on a chatbot, and then 6 months later, that paper and its ideas are actually in a real product. And that felt very impactful as well. And I actually realized after 2020, we've developed enough research to be able to have more impact in the applications of this research, rather than inventing yet another variation of a transformer or an even bigger LSTM or something like that. And I think in the next decade, there's some similarities to electricity in that the basics are well understood well enough to be able to very usefully employ those ideas in real applications, instead of just thinking more about the underlying underpinnings of it. And of course, like electrons don't really move, and it's all fields, and like the abstractions were kind of wrong, and they're probably wrong also for AI, but they're well enough understood that we can make very useful applications of it. And I think that's where we are in deep learning right now. And so I'm very excited to basically build a ton of interesting applications in it. And I'll just share with you two things that I now mostly work on. Basically, after I got acquired by MetaMind, I kept my PhD student lifestyle, didn't really spend much money. And so I invested that money in my friends. And I was very fortunate to have had a ton of very smart friends and interns and coworkers and employees and so on, who have since started great companies. And so I started investing a bunch during my Salesforce times as an angel investor. And then when I left Salesforce a year and a half ago or so, I could actually start a fund. And I tried to scale, again, think about positive impact and kind of scaling that impact. And the one sad thing about scale is that your personal hours don't scale beyond 24 per day. I tried, it just doesn't quite work. I do need sleep eventually. It's not long-term viable to try to sleep less and less and so on. And the way to scale is you find other smart people and you work with them. And so I started this fund called AIX Ventures about a year and a half ago or so, actually a little bit less than, around a year ago, after I'd left Salesforce. And my main goal after leaving Salesforce was to build a better search engine. And so I'll talk first about the fund a little bit, and then about the search engine and why I think it is actually possible. And we've actually done it to build a better search engine than Google. Now, I'll just talk a little bit about different kinds of companies. Quick show of hands, who here works in something that could be construed as an AI startup? All right, almost a little more than half maybe. So I think there are going to be two successful groups of AI startups. There's going to be a few, maybe at most 24 or so, horizontal startups. Horizontal in terms of looking at the Software 2.0 stack. And Software 2.0 is basically, I think, the new way to do software engineering, where instead of you telling what the computer should do very explicitly, for loops and if then else statement and things like that, you train your systems with the data. And every company that is, that understood the impact that AI will have on the industry is going to want to own the process of creating its own AI systems. And the machine learning experts in that company want to feel like they're in control and they know what's going on. But they don't really actually want to do all the hard work of taking a paper and implementing it with all of its complexity. And that's why they just download a Hugging Face model from the Model Hub. And they don't actually want to do all the complex experimentation and experimental tracking. That's why they use weights and biases to track all their experiments and look at the different models and know when to quit model training and updated, especially as these models cost like millions of dollars to train, which is true for large language models. They don't really want to do that. They don't really want to go out and build a labeling interface and then find 10,000 people in the Philippines to label all their data. So they use scale.ai, which is also a unicorn now, but sadly I haven't invested in it. And they don't really want to do all the ML ops and load balancing and stuff to really get that model running in production. So they use ZenML, which is actually one of our German investments at AIX. And so that's sort of the set of horizontal startups. And there's going to be a few winners, but I don't think the space is big enough to support all of the different startups in that space right now. There are going to be a few winners. Hugging Face is actually an incredible story of, I think, of one of the most successful pivots in AI startup history, because when they first started, there was a chatbot, sort of a chatbot girlfriend, and that would basically cheer you up and send you, cute Hugging Face emojis and stuff. And that's when I invested, because, I watched the movie Her. I knew NLP is going to improve. The founders had taken my class. They're really smart. I mean, they weren't even at Stanford. They're just at living in New York, but they kind of remotely took the class because I uploaded all the videos, which then Stanford kind of yelled at me for. I had to take them down, but different story. And so they're really, really smart. They're working on technology that's going to improve a lot, and I trusted them to figure something out. And then as they kind of tried to scale the chatbot and get more users in this consumer-facing world, they also put out these different kinds of papers and their implementations of these very recent AI papers. And their GitHub repository just kept getting more and more stars and forks and contributors. And initially, they really just did that to hire the right people and to sort of make it easier to build a good team. But eventually they realized this is the actual value that's being created. It is in the course and the models. And so incredibly successful pivot. Now, they're being used by tons of different companies, even like large companies like Apple and Google also use them and contribute back their models. They're now increasing not just support modeling, but also data sets and so on. So it's a very, very impressive story. And despite the recent downturn, they're still very popular, and a lot of folks are reaching out, trying to buy secondaries and so on of them. Anyway, so there are going to be few companies that have captured this horizontal new software 2.0 stack. And then there's going to be, I think, hundreds, if not thousands, of verticalized AI companies that are basically looking at one vertical. They find some company that still uses fax machines or some company that uses some old process, and they just take AI and optimize that process massively. And Athilas is one such company. Tanay, their founder, was one of my interns actually twice. And Athilas is now much more successful than any company I've ever built, which is really great to see. But basically, they started out from blood tests. And the blood test, he basically built this device when he was still in high school, where you prick your finger, you get these two glass plates, the blood gets sucked into this capillary system between the two glass plates, and then he built just a simple self-focusing microscope, and you can look at those samples, and you're like, clearly, you don't need a person to sit there manually and count the red and white blood cells. You look at the sample, and you're like, any convolutional neural network can automate that. But that was just one aspect. It was an important aspect to be able to, in 5 or 10 minutes, give you a result, but he fully vertically integrated the entire value chain. And then not only that, we looked at like, okay, when is this test actually being taken? It's like when you have chemotherapy and you need to know your red and white blood cell count in order to take a drug that kills the cancer, but also kills you if you take too much of it. Chemotherapy, you lose all your hair. It's like the drugs that you take there, you need to take the exact right dosage. And the way they usually kill you is by reducing your blood cell, like red and white blood cell count, too much. And so you want to take the right dosage. And what's interesting is he basically went further and said, okay, let's just not replace that one test the way Quest Diagnostics and others take the test, which only was a $200 million sort of market cap in the United States. Like people take this test, and Quest Diagnostics and a few others make about $200 million, which is not an exciting enough market for a venture-backed company. But he went further and said, well, this test is being taken for these drugs, but if you can take the test and 10 minutes later get the result for $10, $20, you can now take the right amount of that drug right then and there, instead of waiting for 2 days and then have, not be able to take quite as much of the drug. And so basically now they became a companion diagnostic where you can only get the drug with the device. And it's fully FDA approved for a bunch of different cancer treatments and so on. And then they went even further and say, well, once you're doing that, you also want to be tracking your weight and you have to take other pills. So now they're doing full remote patient monitoring. And once you do that, then you can it's all automated, it's all digitized. You can then also track with the insurance and automatically file everything with the insurance. So they're just growing. And yeah, they're really crushing it. The AI was kind of the seed. It was a necessary condition, but it was not sufficient to really build a massive company, but it kept growing from that incredible seed. And I think we're going to see a ton of different such verticalized companies that start out with some AI that automates a manual process incredibly well, but the ones that are really going to excel afterwards will expand from that. And so I'll just share with you a couple of other investments. Vivo here is an interesting one from a bunch of UCSF researchers that basically found a way to test different kinds of cancer drugs within one mouse. So usually you take one mouse, you have one type of cancer, and you can test one drug, and then have to kill the mouse and dissect it and analyze everything. And they found a way to do that, but 100 times within one mouse, and then kind of use AI to deconvolve and see how each drug affected multiple different types of cancer cells. Atmo, also really exciting. They basically realized that with AI and large neural networks, they can improve weather forecasting massively. And while it's not super cheap to build these massive, large supercomputers, it is still much, much cheaper than what current weather models are doing. And so they can basically sell it now and help countries like Uganda, who they're currently working with already, to have their own weather forecasting service. And especially given climate change and so on, is really important for countries that don't quite have as much money as a lot of Western European countries to have a good weather forecasting service. And I think it's really exciting work, both technically and a really tough go-to-market though. One of the biggest concerns we had with this investment was that selling into governments is incredibly slow. So I would generally discourage any of you to build startups that do that. They have one person who has very deep connections and has worked in East Africa for decades, and was basically had the prime ministers and stuff on speed dial, and that helped a lot. If you don't have such government connections, don't try to sell in the governments, or hire the right people and so on. It's complex. Just to bring home the point here of how much AI will impact every different industry, I'm going to show you a few more examples of recent investments that I'm really excited about. I mentioned ZenML already. It's sort of ML ops, doing all the load balancing and actually running AI in production. Very sort of technical project. They already have a couple of thousands of stars and forks on GitHub as well, and actually a German company. So it was a very reasonable valuation. I think actually you're in a good place right now because in some ways valuations are lower generally because of the economic downturn, and compared to the US, valuations are already lower because in Germany you can kind of just have lower living, costs, and so you can get away with using less money, and that is an alpha or an advantage that a lot of US firms are currently realizing, and so there's more and more money coming into Europe now. And one of the reasons I started AIX is also to invest in German companies myself. Sparrow is an interesting one, and they basically had the insight that in biolabs, there's a lot of pipetting, a lot of repetitive, boring manual labor that PhD students, but also pharma labs and so on are doing. It's not super trivial to just have a robot where you just have if then else statements to automate that, because different liquids have different viscosity and there's a little bit of randomness involved. But with just a little bit of AI and a deep understanding of that space, you can automate experimentation in biolabs a ton, and that's what Sparrow is doing. I think we're going to see a ton in inventory, warehouse management, and so on. And Ware here is using autonomously flying drones to basically go through large warehouses and identify sort of how full different things are and where things are and so on. MoonHub is an interesting one because it's sort of the white collar type work. It's basically a company that helps recruiters be way more efficient. I'm sure all of you are trying to recruit. really smart people, what you do is you have to find who is qualified. That search is surprisingly still very, very hard because you might say, someone might say, oh, I use PyTorch, and you want someone who knows how to program in Python. And if you know enough, you know that, well, if they're good at PyTorch, they probably know Python. But if you just do a string matching search on LinkedIn or something, that will not show up. So they help recruiters be more efficient with better search. And then afterwards, they also help with automating outreach, because you can basically send emails now at a fraction of the cost and fraction of the time it took using large language models and so on. So you can take a job that is currently being done that probably still has to have people involved, but you can make those people 10x more efficient and hence only need 1/10 of recruiters. Beagle is another area that I think actually has a ton of potential, especially also in Germany, which is using AI to automate agricultural processes like in the fields. I think it's a very impactful one. It's also actually, I think, helpful for the climate because in the US, an estimated 20 to 30% of all fruits and vegetables are just lost in the field because farmers can't find enough people to just pick them up. It's crazy. It's kind of interesting because a lot of people are like, oh, we're going to lose all the jobs. What are we going to do with our time? And it's like, no, we don't have enough people right now. It's kind of the opposite. I do think that's going to be a short-term thing, but yeah. So Beagle in particular, like prunes wines and vineyards and stuff like that. There's tons of other companies that, pick different kinds of berries. And once you actually figure out like really fully the end-to-end process to pick one fruit, you're already worth like $50 to $100 million to like John Deere and other tractor companies and so on. So robotics is still hard. Hardware is hard. If you are good at software and you have good ideas for software, I would still encourage you to work more on software. But if it's a lot of competitive mode if you can figure out a real hardware problem and solve it well. Ubenwa here is a really cute one. Basically, they analyze infant cries and then identify what the most likely cause is of why that infant is crying and screaming. I'm not a parent myself yet, but I've been told that it would be very nice to disambiguate all the crying sounds for babies. Basically, every industry out there is going to be improved and impacted by AI. I maybe just do one more, which is Meta.ai. They are basically reducing methane emissions from cows. So fun fact, methane is a greenhouse gas. It's 84% more potent than carbon that we often talk about with carbon credits. So if you take out 1 unit of methane, it's worth 84 times the carbon credits to folks. That's sort of the multiplication. And they're doing that by using AI to optimize the diet of cows so that the cows burp and fart out less methane. And it's very interesting because they just finished a bunch of interesting science. One of the reasons I love this job and love investing, you learn all kinds of interesting fun facts. But just all the methane emissions from just cows, it uses as many greenhouse gases as the entire United States with everything else combined. All driving, all flying airplanes, all cement creation, all of that stuff is the same amount as greenhouse gases as all the burps and farts of cows. Kind of insane. So hugely impactful, very hip. Coca-Cola, big companies, they have like 3 goals, like well-being of the cows, which I think is great. And then forgot the second one, but the third one is basically reduce greenhouse gases from that cow and milk production. So very exciting. And what's interesting, last interesting fact here is it seems like when you change the diet, you add like certain algae and stuff to the cow, a few months later, the cow will go back to farting and burping out the same amount of methane as before. Like it works briefly, and then somehow their microbiome adjusts and goes back to the original methane output. So very interesting. If you have any company in the convex hull of any of those kinds of companies, I'd be interested in chatting and investing in your company. A bunch of other cool investors for follow-on investments and co-investors and so on. Now, one interesting thing about AIX that is very different to any other venture fund is that we actually have a team, including myself, of people who have full-time jobs that aren't just investing. And I think that's important because AI moves so quickly, it's very easy to lose touch with the cutting edge in the field. And so we have these incredible individuals that are world famous, roboticists with Peter Beal, natural language processing researchers with Chris Manning, my former advisor, Suchi Surya, who also did her PhD at Stanford, is now a professor at Johns Hopkins for AI and healthcare and runs Bayesian Health, an AI healthcare company. They work on like things like sepsis and things like that are super important and still not very well understood. And we got Anthony Goldblum too, who was the founder and CEO of Kaggle for many years until recently. Kaggle is the biggest machine learning competition and community site. And yeah, he's seen a ton of really interesting companies in the space of especially this ML tooling and software 2.0 stack. So yeah, that's kind of our model. And so with that, I'm going to transition to what am I doing outside of investing? And the answer is U.com. So I'm going to show you just a little bit of why I think it is actually possible to build a search engine that's better than Google, which a lot of people think is kind of crazy. And it is kind of crazy. I admit it. It's not super obvious, but I'll show you one example that I think brings home how much better we can actually be. And it's relevant for a lot of you because you're programming and you care about efficiency of your own life. And so if you're on Google and you're trying to program something such as, maybe this random one here, Python Fibonacci direct computation. Now you can go to Google and you get your Google results, a bunch of blue links, and you're like, okay, open a dozen tabs and scroll through a bunch of websites. And after 5 minutes, maybe I have my answer. Or you can go to U.com. And first thing you're going to see is a Stack Overflow app with a code snippet and a copy and paste button. And you just save 5 minutes of your time. And according to a bunch of studies, programmers spend about an hour of every day finding answers, solutions, code snippets, and so on online. And so if you use U.com, you probably save 50 minutes and you're much more efficient. And you probably will find better code. You have different tutorials here and different ways to implement that function. And worst case, if there is no real answer from someone else, you can ask an AI to basically write anything for you that might not have been written yet. So there's an AI code complete function. There's one that will create regular expressions for you. There's one to create a Kubernetes-like tools. There's one that will write SQL code for you. All of that right within the search results. And when you look at this, you're just like, yeah, this is obviously better. It still took us a while to really make sure it is almost always better, especially for developers. But we actually just like 2 months ago, and we continuous testing with external people who don't have any feelings about they could get hurt from us and so on. They don't care, and we now are like, according to external studies, actually better than Google for developers. And so a lot of our queries are developer-based queries, and you can see there's all kinds of things. How to sort of dictionary by value here. Again, super useful code snippets of various kinds. AI that will write various modifications of that function, and just generally useful results. And what's interesting is we thought, man, we're never going to be able to compete with Google AI, right? They got DeepMind, they fold proteins, and they build, spend hundreds and hundreds of millions of dollars on AI. How could we beat them on AI? Yet, I don't see Google having like an AI that writes code for you in the search results. And they're kind of sleeping through all the other major things. So if you search for how to write well, you want to write an essay, or you need to write a paper, or you need to write some kind of email, and you're like, how do I phrase this thing? You just say what you want to say, like at a high level. And then, if you search for how to write well, or you write, then you just have an AI that just writes it for you. And it's basically, again, a large language model that will generate you, arbitrary text. You can say if you want to be professional or witty or friendly or neutral, and say what kind of, text you want to produce. And then you'll just have it written. And if you're a marketer, for instance, this is going to change your job massively, right? Marketers have to write blog posts about products and so on. And, any kind of product you want to describe, you just put it in here, and then it'll write it for you. And here I just, created one yesterday about the German startup ecosystem. One interesting thing, actually, the BMWI has been renamed recently, like last year or so. So it has not incorporated that yet. So obviously don't take it with a grain of salt, or take it with a grain of salt and like double check whether what it says actually makes sense. But more often than not, it just kind of works. And here, this is a good example. I think at some point, you're not going to want to trust all of its numbers. Like, it just sometimes creates random numbers, but more often than not, it just gives you a good first draft. And again, it doesn't have to fully replace a person, just has to make a person 10x more efficient, and you'll still be better off. And so since there's sort of two exciting areas of generative AI recently, there's a third one, namely digital art and stable diffusion types of generations. So if you search for digital images of Gustav Klimt, then you have your standard web results that you'll probably also find on Google, and standard image results. But we also have Lexica, which is lexica.art, is a really cool new sub-search engine only for digital images that are created by AIs. And not only that, but you can yourself say, well, I want to create a new image. And so here, I asked it to create an image of a woman with an iPhone taking a selfie in the style of Gustav Klimt. And boom, I got one. So if I now have a blog post that the AI had just helped me write, and I want to visualize it, because we know there's SEO improves search engine optimization if you have a little image, or you just want to put an image on your slides like I just did, then you can do it. And so that none of those features are on Google, even though they spend hundreds of millions of dollars on research. And it shows you that as a small startup, you can actually beat a massive incumbent because they're just really slow. And so just played around with a couple of other ones. This one was a venture capitalist walking in Berlin. Again, I don't think they're true fans of Troma, but, just crop the image, still done. So AI is not going to be perfect, but AI will make us all much, much more efficient. And so, yeah, with that, I hope we have, we have like 10 minutes or so for questions. So thank you.
Anybody has a question?
Hi, thank you very much for this super interesting talk. How does Stack Overflow like it if you don't send users from u.com their way?
Great question. So we actually have a couple of other companies that where it's quite different. So the interesting thing and the nice thing about Stack Overflow is that they don't actually own the code snippets and these answers. They're all user generated. And technically, the users accepted a terms of service where they're in a public domain when they use the Stack Overflow website. So Stack Overflow actually has full data dumps that you can download. And so it's fine. Interestingly enough, Stack Overflow actually doesn't make money much on their consumer side. Their main revenue stream is having company internal Stack Overflow instances where company internal coding answers are getting searched for and answered. And so they're fine. I actually talked to their CEO and stuff. Now, it's very different if you are a company that, for instance, makes money with advertisements or affiliate links. And so here, we partnered with the company Loria, and actually also European. They use large language models to summarize thousands and thousands of user reviews. And that is their bread and butter. And they would not like it if we just took all their content and showed it. But the way we're thinking about u.com to be equitable, but also really useful, is to make it an open platform.
Thank you very much for the talk. It was very interesting. Does u.com also implement its own search engine?
It does, yeah. So it's complicated. So there are three things. We crawl a bunch of stuff ourselves, but crawling the entirety of the internet with very long tail stuff, we estimate costs about $20 to $30 million a year. So you got to have like hundreds of millions of users, and we're not quite there yet. Though we are kind of hockey sticking right now, which is exciting to see. And so it doesn't make sense for us to crawl everything all at once for every language and so on. But we're crawling more and more and are doing all the indexing and like extraction of different things to make it very useful, like these kinds of things and the side panel, all of this, like we've crawled. All right, one more quick one, and then I got to run to the airport. Sorry.
Just a quick question. How do you how do you think about using GPT-3 for search, right? We see a different user behavior, and GPT-3 has, stuck in 2018 knowledge, but it does very comfortable. If you can just ask anything GPT-3 and it just gives you one answer, and it's usually quite accurate. So,
this is similar to GPT-3, and we actually run an experiment. Sometimes it is exactly GPT-3. And not only is it stuck in 2018, but you can't actually rely on a lot of its answers. Our values are trust, facts, and kindness, both internally as a company and in our product. And you just can't trust the facts. Like if you ask, and actually, I don't know if this is still true on Google. We have these banks too. If you go to Google and you ask, like, when did the first person land on Venus? And then, they fixed this now, but we'll see. So they used to just tell you, like, this is the date, right? And now they got a little bit better, actually. It's a new table. So this has changed in the last couple of weeks. But, the fact is that there was no human has ever landed on Venus, right? There is no person on Venus, and saying it happened in 1970 is not right. And so these language models will go even more absurd. And you're like, why does like a chicken run the company as a CEO? It will tell you something, and so I think language models are an important piece. We use language models a lot in the back end in a variety of ways, but you can't just let it run loose. Also, it's not as fast, like I want to create another essay here. It will take a few seconds. In search, it's so brutal, but like every 100 milliseconds, like we have user satisfaction improves with every millisecond. And so on. Like you got to be extremely fast, and these large language models aren't fast enough and they're not accurate enough. All right, thanks so much. Wish I could hang out more.
Thanks for coming, Richard.
Thank you.